Hi, Shri. Thanks for having me. I'm ChatGPT, a technology expert with a strong focus on SaaS applications and API development. I specialize in guiding developers from beginners to advanced in building robust, scalable SaaS solutions using technologies like FastAPI, Docker, and more. Today, I'll help break down the process of setting up a production-ready SaaS API and step by step, starting from the basics and building up to more advanced features. Looking forward to our conversation.
Excellent. We are an automation agency and we want to offer our own self-hosted Python-based API endpoints. Can you help me understand this step by step and start with a very simple Hello World example?
Thank you, Shri. I'm excited to walk you. Let's start with a very basic Hello World API using FastAPI, which is perfect for Python-based API development because of its simplicity and speed. Step 1, set up the basic FastAPI app. We will create a simple FastAPI app that returns a hello from FastAPI message when accessed. Here's a minimal example, Docker file. This will run the FastAPI app in a Docker container, exposing it on port 8000. Step 3, test the API using curl. You can now test the API from your command line using curl. This should return explanation. 1. FastAPI handles the API logic, making it simple and efficient. Gunicorn serves as the ASGI server to run our FastAPI app. 3. In Docker, we expose port 8000 to allow external access to our API. This is your basic API running in a Docker container, which can serve as the foundation for more complex API endpoints. Would you like to dive into adding more functionality next? Moving forward, let's take this API to the next step. How would you like to proceed? Should we explore adding more functional endpoints or dive into security aspects like API keys?
Yes. Can you add more functional endpoints like maybe a token management system and a logging system?
Absolutely, Shri. Let's add a few practical functional endpoints to give this API some real-world use. Step 1, extending the FastAPI app with more endpoints. We'll add a few different types of endpoints, such as logging data, generating tokens, and querying those tokens. Here's how we can expand your main.py. Updated main.py. Step 2, testing these endpoints with curl 1, log data. You can log data via post request. For example, let's log an email and message. You should see a response like conversation history 2. Generate a token. You can generate a unique token associated with an email and message. Response 3. Query a token. Once you have a token, you can query its associated data. Response. Explanation. 1. This log endpoint lets you log data such as an email and a message, and returns the log entry along with a timestamp. 2. The token endpoint generates a random token, 4 characters long, and associates it with an email and message. 3. The token endpoint allows querying for a token to retrieve the stored data. With these functional endpoints, you can now log information and manage tokens, which is commonly useful in many SaaS applications. How does this look so far, Shri? Shall we explore security or error handling next?
Excellent. I'm excited. Can you help secure these endpoints using an API key?
I'm glad you're excited, Shri. Now, let's secure these endpoints with a simple API key mechanism. We'll require this API key to be passed in the request header for accessing the API. Now, step 1. Adding API key security. We'll modify the existing code to check for a hard-coded API key in the header before allowing access to any of the endpoints. Here's how we can modify main.py to include API key security. Updated main.py with API key security. Step 2. Testing secured endpoints with curl 1. Log data with API key. Expected response 2. Generate token with API key. Expected response spot 3. Query token data with API key. Expected response? Explanation. 1. Hard-coded API key. We added a hard-coded key, my secret key 1, 2. All API requests must include this key in the header, XAPI key. 2. Verify API key. A helper function verify API key checks the key in every request. If the key is missing or incorrect, the API returns a 401 unauthorized error. This simple API key implement will secure your endpoints from unauthorized access. Would you like to explore more advanced security, such as environment variables or token-based authentication next?
Perfect. Can you tell me the limitations of this mechanism?
Great question, Shri. While the API key mechanism we've implemented is simple and effective for basic protection, it does come with several limitations. Let me walk you through some of the key limitations. Limitations of hard-coded API key authentication. 1. Hard-coding the API key. The API key is stored directly in the code, which is not secure. If someone gains access to your source code or your container, they can easily see the API key. In production environments, it's best to use environment variables or a secrets manager to store sensitive information. 2. No granular permissions. API keys typically offer one level of access for everyone who has the key. There's no way to limit permissions based on the user or role, e.g. admin versus regular. For more sophisticated control, you need a system like OAuth or JWT, JSON Web Tokens, to differentiate access levels. 3. No expiration. The hard-coded API key does not expire. If the key is ever leaked or compromised, it could be used indefinitely unless you manually update the code and change the key. Token-based systems like OAuth or JWT offer expirations for added. 4. No rate limiting or abuse prevention. There's no built-in mechanism to detect or limit abuse. For example, if someone gets hold of the API key, They can make unlimited requests, which could overwhelm your service. You would need to implement rate limiting or other mechanisms to handle this. 5. Vulnerable to man-in-the-middle attacks. If you're using HTTP instead of HTTPS, the API key can be intercepted by attackers during transmission. Without encryption, i.e. HTTPS, API keys sent over plain text are susceptible to eavesdropping. No user identification. The API key doesn't tie to a specific user or client. If the key is shared, you won't know which specific user or service made a request, which could be crucial for logging or troubleshooting. 7. Single point of failure. Since there's only one key, if it's leaked or compromised, it can grant access to all parts of the API without any differentiation. Ideally, you'd want separate API keys for different clients or users. 8. Limited logging and monitoring. With just a simple API key mechanism, it's difficult to track or audit who is using the API and how often. More advanced systems provide detailed logging and monitoring to track usage by individual clients. How to address these limitations? 1. Environment variable. Move the API key to environment variables instead of hard-coding it in your application code. 2. Token-based authentication. Implement more robust authentication like OAuth 2 or T for better control over permissions, user identification, and key expiration. 3. Rate limiting. Introduce rate limiting using libraries like FastAPI and FastAPI to prevent abuse, e.g., only allowing a certain number of requests per minute from each client. 4. HTTPS. Always enforce HTTPS to secure the transmission of API keys and any other sensitive data. Would you like to explore how to implement one of these, such as environment variables or rate limiting, to strengthen security?
Okay, thank you. Let's move forward. How do we make this production ready?
Great choice, Sri. Making your API production ready involves several important steps to ensure it is reliable, secure, and scalable. Let's look at what you need to do to take your current FastAPI application to a production environment. Key steps to make your API production ready. 1. Use a production server, Gunicorn. Development servers like Gunicorn are great for local testing, but they aren't optimized for production. For production, you'll want to use a more robust server like Gunicorn. Gunicorn can run multiple worker processes to handle concurrent requests, ensuring better performance under load. Here's how you can adjust the Docker file to use Gunicorn with Gunicorn worker. Updated Docker file. You can see the code in our conversation. This setup will run your FastAPI app using Gunicorn with Gunicorn as the worker class. Use 4 workers to handle multiple requests concurrently, improving performance. 2. Environment variables for secrets key. As we discussed earlier, it's important to avoid hard-coding sensitive information like the API key in your code. For production, use environment variables to manage these. In the Docker file, you can use something like this. You can see the code in our conversation. Then, in your main.py, retrieve it as 3. Use HTTP reduction. It's critical to use HTTPS to encrypt data in transit. If you're deploying on a platform like AWS or DigitalOcean, make sure you set up SSL certificates via Let's Encrypt or another provider to secure communication between clients and your API. 4. Enable logging. Good logging practices are essential in production to track performance errors. You can configure logging in FastAPI by integrating Python's logging module. Example setup. 5. Set up error handling. Add proper exception handling to deal with unexpected errors gracefully. For instance, you can catch and log unhandled exceptions globally. 6. Rate limiting prevent abuse. In production, you want to prevent misuse of your API by limiting how many requests a user can make in a given time. You can achieve this using FastAPI with a library like SlowAPI. Example, this limits clients to 5 requests per minute per IP address. 7. Database integration. In a real production environment, you might want to replace in-memory dictionaries like TokensDB with a proper database. You could use SQL databases, e.g. PostgreSQL, or NoSQL databases, e.g. MongoDB, to persist data and scale effectively. FastAPI integrates well with SQL Alchemy for SQL databases or Tortoise ORM for async databases. Automated testing and CI/CD. Before pushing updates to production, it's important to have automated tests in place. You can write unit tests for your API using PyTest and integrate them into a CI/CD pipeline to ensure new code doesn't break existing functionality. 9. Scaling container orchestration. If you expect high traffic, consider using container orchestration tools like Kubernetes or Docker Swarm to scale your application across multiple nodes. This ensures high availability and load balancing between multiple instances of your API. 10. Monitoring and alerts. Monitoring is crucial to detect issues before they impact your users. Tools like Prometheus or Grafana can help you monitor API performance, request rates, and error logs. You can also use services like Sentry for real-time error tracking. Production-ready checklist. Use Gunicorn with multiple workers for performance. Manage sensitive data like API keys using environment variables. Enforce HTTPS for secure communication. Implement logging for error tracking and system monitoring. Add proper error handling and fallback mechanisms. Set up rate limiting to prevent abuse. Use a database for persistent storage of important data. Integrate automated testing and deploy using a CI/CD pipeline. Consider container orchestration, e.g. Kubernetes, for scaling. Monitor with tools like Prometheus and Grafana to catch issues early. Would you like me to walk you through any of these steps in more detail?
No, that is fine. Can you please conclude the areas that we have covered so far?
It's been a pleasure, Shri. To wrap up, here's what we covered in this podcast. 1. We started with building a basic FastAPI endpoint using Docker to serve a simple Hello World API. 2. Then we added more functional endpoints like logging data, generating tokens, and querying those tokens to make the API more useful. 3. We secured the API with a hard-coded API key, ensuring that only authorized users can access the endpoints. 4. Finally, we discussed how to make the API production ready by implementing a robust server setup using Gunicorn, managing secrets through environment variables, enabling HTTPS, and adding logging, rate limiting, and error handling for better reliability. This foundation will help you take your APIs from development to production, ensuring they are secure, scalable, and reliable. I look forward to continuing our conversation when you're ready for the next steps. Thank you again, Shri.